Okay, I still don't understand why I select attribute, it won't work, but what I did was I go to pools that I build a definition query that make you cannot use select by attribute and then you export data. It doesn't work. I don't know why. Even I use this, I do multiple ring buffer, it won't work. So if we get rid of this and we say, let's do select by attribute again, and we have a pools, new selection, and we can add a clause. So we should say pools open equals to 1, right? And then we click add, and then we click run, and we select the system. And let's do multiple ring buffer. Okay, tools. Let's do multiple ring buffer. We will say pools. Okay, and then, yeah, multiple ring buffer. Okay, we do 0.5. And then 1. And we will do miles. And we click run. Oh, no. I want 1 here. Click run again. Okay, so we will say 5. Okay. We will delete the 3. Oh, shoot. Remove this one. Okay. Alright. Then I think the 5 works. So, yeah, the 5 works. So, in this case, it worked. But you cannot export it. If you export the selection, it won't work. Now it worked. Or you can do definition query. And right now, go back to map. I can clear selection, and I will do symbology, and then we'll do a spatial join for you real quick. And I just do green. Nope, no color. And then green, Irish color. There, okay. And then I will do is go back to analysis tools, spatial join, and spatial join we will say ring buffer 5 join to the Pittsburgh centroid, and that's fine 1 to 1, and we select this, and we will go to sum, and we will sum it, click run, and once we have it, we right click on it and go to open attribute table. So that's how we get the data. So the procedure, let's walk through again. We find a good fair use access for pools that remain open, and we select pools using select by attributes with the criterion open is equal to 1. Yeah, we did, and you cannot export it. I find problem there, but you can do select attributed, and then you run the multiple ring buffer and perform a spatial join of the block centroids to the new buffers, and then we get the totals for good and fair access. We will find that 10,726 have a good access and 20,450 have a fair access, compared with 21,833 who had a good access and 20,725 who had fair access. When all pools were open, why don't we suppose that fair access remained so high? Maybe it is the conversion of good access to fair access, or maybe it is because with all pools open, there tended to be access to more than one pool for a given residence. Where areas with pool closed, there was still fair access, but to only one pool. In any event, now only 63.77% of the youth have a good or fair access, compared with 87% with all pools open. Now, we can just save it and then go to save and click yes. And we will go to the gravity model. So multiple ring service area for calibrating a gravity model. Yeah, save all the edits, and then I will bring this back. So for gravity model, let's see if we have it here. Gravity model. We didn't introduce gravity model. It's not this. Okay, this one didn't introduce. Let's open this and then we will talk about it slowly. So multiple ring service areas for calibrating a gravity model. The service areas are similar to buffers but are based on travel over a network, usually a street network data set. If a point, say for a retail store, has a 5-minute service area constructed using ArcGIS Pro's network analysis tool, then anyone residing in the service area has at most a 5-minute trip to the store. If we have a permission from the instructor, we can use ArcGIS Online service that consumes credits or otherwise have access to the ArcGIS Online credits. We could use an ArcGIS Online network service. I think I did the network service before, which would be much more accurate than the free Tiger-based network dataset we will use here. Nevertheless, we will use the Pittsburgh Street ND network dataset. Network dataset ND means network dataset provided here so that we will the results of match the tutorial results. So now we will use the service area to estimate so-called gravity model of geography, known as the spatial interaction model, which assumes that the further apart two features are, the less attraction between them. The fall of attraction with distance is often nonlinear and rapid in a Newton's gravity model. In physics, the physics objects where the denominator of attraction is distance squared. So the application of this here is the continuation of the pool case study based on random sample of youth-only pool tags, which allow admission to any Pittsburgh public pool. To scale the random sample up to the full population of youth with pool tags, we will need to multiply estimates by 11.3. With services area, we could use distance or travel time to estimate a gravity model. Here we will use time minutes. So this we will do the multiple step workflow here. Number 1 is select open pools for the feature layer of all pools so that the service area of the next step is applied to only open pools. And then the second step is create service area for a given set of travel time 1, 2, 3, 4, 5, and 7 minutes to produce non-overlapping service area rings. Then the result is the central area and 4 rings 0 to 1 minute, 1 to 2 minutes, and so on. So this time were determined by trial and error to get good sample sizes in each ring and cover the catchment areas of pools. Number 3 is count the number of pool tags in each service area. The count is accomplished using a spatial drawing of the service area and service areas and pool tag points. When scaled up by multiply by 11.3, the result is an estimate of the number of youth owning pool tags who will use pools in each service area ring. So, and then we sum up the population of youth ages 5 to 17 in each service area. We will use using a spatial drawing of the service areas and block centroids. The result is the target total population for pool use of all youth in each service ring. Calculate the average use rate for each service area as percentage using rate 100 times 11.3 times number of youth with pool tags in sample divided by total population youth, and plot the estimated use rate of each service areas versus a versus the average travel time in each service area in minutes for the nearest pool 0.05, 1.5, 2.5, 4.0, 6.0. Use rate is expected to decline rapidly with travel time. So note for the technically advanced student, so we can make more accurate estimate of the average travel time for each service area ring of step 6 using an original destination OD cost matrix calculated using a network analysis tool. We will search OD cost matrix analysis in ArcGIS Pro Help. We can configure this matrix to record the shortest path, distance or time between each command point, origin, and supply point destination. In the current problem, the block centroids are origins and pools are destinations. Manipulations of the OD matrix, say in Microsoft Excel, can yield exact averages or medians of travel times for a ring instead of assuming that the midpoints of service area rings are average travel times. So now we have this open, and we will zoom into Pittsburgh bookmark, and the map has 22 public pools, both open and closed, and the block centroids symbolized with youth population age 5 to 17. And tool text, the map also has a network dataset for Pittsburgh Street, network datasets built from Tiger Street center lines. The network dataset is calibrated for drive time in a vehicle. And now we're going to turn off pool tags in the Pittsburgh block centroids. Pool tags. And then we will select by attributes and complete its geoprocessing here, and we will run and close the geoprocessing pane. When we add the facility pools to the network analysis, we will open the only open tools will be added. So now we will go back to select by attribute, and we will say pools, new selection, pools, new selection, and we will do add class open equal to 1. Click add, click run. And then we will create multiple ring buffer service here. So now on the analysis bar, we will click the network analysis button. Back to analysis, multiple ring buffer, and we will say we want the tool is network analysis. So analysis tab, click the network analysis tab. Right here. Network analysis service area. Okay, and then if we don't see the network analysis button, we will make sure that ArcGIS window wider because the contents pane has a network, a data set. It's right here, network data set. And then the item on the network analysis list are enabled. ArcGIS Pro builds the service area group layer in the contents pane and adds the network analysis service area contents menu to the ribbon. And it's right here. And on the network analysis contextual tab in the input data group, we will click import facilities, make sure the selection is shown, and then we will run the tool. We will add a location tab and input. So on the network analysis contextual, okay. And we will have import facilities. I don't see import facilities. Maybe it's not here. Not this one. Okay, I don't need this. Alright, so on the network analysis context tab, input. Okay, we already have. Oh, no. I don't want to add a new one. Okay, let's remove this, and then network analysis, facilities, click import facilities, go to data,